Hello, 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 hello. Unit 8, lesson 4. Okay, gets a little confusing here. More work with square roots. We were introduced to some of this couple units ago, couple sections ago, where we're talking about our unit fraction exponents right here. Okay, put it on the board. Remember I said b to the 1 over n equals nth root of b. Okay, just like I think I used x like this, where x is to the 1/2 power. Okay, so just know that rule. You might have to switch it back and forth. Just be very careful what is underneath the radical, what is being raised to the power. So we saw one of these questions. It was a multiple choice question. You want to rewrite it in the expression form ax to the b power. So here's your square root of x, which is x to the 1/2. So I have 5x to the 1/2 power. Okay, here is my fifth root of x, which is x to the 1/5 power. Okay, but you have to be careful. Okay, that's a 5. You have to be careful because what this actually is 1/4 x to the 1/5. That's probably how you'll see it written. You won't see it as x to the 1/5 over 4. Okay. The next one, here it is down here. So it's x to the 1/3. But now that's in the denominator, so it's actually 7x to the negative 1/3 because of a prior property with logs and fractional exponents when the exponent is in the denominator. This one's real tricky, okay, because it's just right here. Okay, so that's x to the 1/10. So then we have 5 over 3. And then since it's 1 over x to the 1/10, it's actually x to the negative 1/10 like that. Okay? So there you go. That's how you change them. A lot of little review there. A lot of things that we did. Hi there. What's up? Now, here is another rule. Okay? So you're not always going to have 1/5, 1/2, 1/3. You could have a power underneath the radical as well. Okay, so what we do there is we just take that out of there. Okay, we take that power underneath the radical, put it outside parentheses, and then what you have is b to the 1 over n raised to the m power. Power to a power you multiply, and that's how you get b to the m over n over here. Okay, so like this one here, we'd rewrite to the square root of x raised to the 7th power. Square root of x is x to the 1/2 raised to the 7th power, which is x to the 7/2. Okay. Now, of course, I'm gonna show all the steps, and then as you get better at it, you can skip the steps. So what do we have here? We have the 4th power of x raised to the 6th. So it's x to the 1/4 raised to the 6th power, which is x to the 6 over 4, which is x to the 3/2. Okay, power to a power you multiply. And then, of course, if you have a fraction that can be simplified, by all means, simplify it. This one's already done for you. So we have x to the 1/2 raised to the 6th power. 1/2 times 6 is x cubed. X to the 1/3 raised to the 10th power is x to the 10 over 3. And you could leave it just like that. Don't change it to a mixed number. Okay? If f of x equals your expression, which of the following represents the value of f of 4? So, again, we always use the calculator. So put 4 in for x, or, something, just do the such that x equals 4, and you should get 74. You can try that. Okay, you can try that in your calculator. Okay, now, which of the following is not equivalent? So, how do I rewrite this? I could rewrite it as 1 over x to the 7/3. Okay, it's not equivalent, so that's good. Okay, what else could I do? I could also rewrite this down here as x7 cube root 1 over, okay, which is choice 3. Okay, now, because I wrote it like this, I can't write it like that. So this is the choice. Okay, now this one here, where the heck does that come from? Well, what happens there is you have to give the numerator and denominator a cube root. So we have the cube root of 1 all over the cube root of x to the 7th, right? Yes. Okay? Cube root of 1 is 1, so we have 1 cube root x to the 7th. There you go. Okay. Now, of course, it's a multiple choice. You can always do it, plug it in with such that. All right. Now, this next part gets a little tricky. I mean, I apologize if it's a little longer than usual. Might go 12, 15 minutes, but Kirk is 31 minutes. So hopefully this recorded for you. Okay. So now we are looking at square roots. We already saw the exponent property. We're going to break down square roots with perfect squares. So of course, you know this exponent property. Remember, a to the n, b to the n, right? Square root, we want to simplify square roots. So we want to find two numbers that equal 28, one of which is a perfect square. So it's a square root of 4 times 7, square root of 4, square root of 7. So we have 2 root 7 as your answer. Okay? So we did the square root of both of them. So that's kind of what we did right here in the generalizing of it. So we broke it down to the product, and then we took the whatever the root is, gave it to both of them, and we have the nth root of A times the nth root of B. So it's kind of another distributive property. Okay? Simplify each of the following square roots. So I might run out of room. Hopefully I don't. But what we want to do is we're simplifying square roots. If you want to break it down, the square root of 18, square root of x to the 4th. Okay? Every part of the term should get its own square root. So then this will break down to square root of 9, square root of 2, which is 3 root 2. Now, the square root of x to the 4th. Okay? What we want is we want to find the largest even number. So here's your even number 4, so I don't have to do anything with it. So it's x to the 1/4, x to the 1/2 raised to the 4th power, which is x squared. So it's 3x squared root 2. Right there, that guy right there. Okay? We change colors. Okay? Now the next one, everything gets its own square root. Square root of 200, square root of x to the 5th, square root of y cubed. Okay? So the square root of 200 is the square root of 100 times the square root of 2, which is 10 root 2. Square root of x to the 5th, you want to find the largest even number that is less than or equal to the power. So the power is 5. The largest even number that is less than that is 4. So this is the square root of x to the 4th, square root of x. Okay? Square root of x to the 4th, x to the 1/2 times, or raised to the 4th power, which is times. So that's x squared root x. Okay? Y cubed would be square root of y squared, square root of y. Square root of y squared is just y, and then you have root y. Okay, I'm going to put it above it, the answer. So then everything outside is 10x squared y. That's everything outside the radical. Everything inside the radical, 2xy. You might have to watch that one again, okay? That might have gotten a little tricky on you, all right? So I'm going to erase this and go to the next one. Okay. So, blue, we'll go blue. So we have what? We have square root 147, square root x 9th, square root y to the 4th. Now, 147. You want to find a perfect square that goes into 147. So, 147 divided by 4, does it work? No. 147 divided by 9, does it work? No. 147, 16, 25. You keep going on and on and on until you finally get the square root of 49 times the square root of 3. Square root of 49 is 7, root 3. Okay? Largest even number less than 9 is x to the 8. So you have square root of x to the 8, square root of x. Square root of x to the 8 is x to the 4th. Then you have the square root of x. Square root of y to the 4th, that's an even number. Okay? So you just leave it alone, and here I'll show you. Y to the 1/2, because that's a square root, raised to the 4th power. And that's y squared. Okay? So again, up above, 7xy. Oh no, what happened? 7x, I don't know how that happened. xy squared, and then root 3x. Okay, got it. Very tricky, very tricky. Okay? Now, what also can happen is you can have a cube root, you can have a 4th root, you can have a 5th root. So when you're simplifying higher orders, instead of looking for a perfect square, like down here in this one, letter A, I'm looking for a perfect cube. 2, 4, 8. That's a perfect cube, right? So you have the cube root of 8 times the cube root of 2. 8 times 2, 16. Cube root of 8 is 2. And then you have 2 cube root of 2. Okay? Same thing with 108. You can try 2, 4, 8. See if 8 goes into 108. Doesn't work. Next one is 3. 3, 9, 27. Right? Because you're multiplying. 108 divided by 27 is 4. Okay? So you have the cube root of 27, cube root of 4. So the cube root of 27 is 3, and then cube root of 4. That's as far as you can go. Okay? 250. All right? I'm going to find a perfect cube. Again, 2, 4, 8. No. 3, 9, 27. No. 4, 16, 64. No. Okay? 5, 25, 125. Woo! There it is. Okay? Cube root 125, cube root of 2. Okay? Cube root of 125 is 5. Cube root of 2. All right? 128 cube root. So you got to be careful. Sometimes you have more than one number that goes into it. Okay? But you want to find the largest number that goes into it. Okay? So what do we have? The largest one that goes into it would be 64. Okay? So cube root of 64, because that's your 4. And I'll show you the x momentarily. Cube root of 2. So we have 4 cube root of 2. Okay, now, what we're doing here is looking for multiples of the 3. We did even previously because 2, 4, 6, 8, because it was a square root. So we're looking for this number as an even number. But now we need multiples of 3, so 3, 6. Okay, so I'll change colors here. So what this should be is cube root of x to the 6th, cube root of x squared. Okay? So the cube root of x to the 6th, so we have x to the 1/3 raised to the 6th power, which is x squared. And then you have the cube root of x squared. Okay? So that ends up being, I'll go down here a little bit, this ends up being 4x squared, cube root of 2x squared. All right, so you got to be very careful of everything like that. Okay, so that's all. I'm going to stop there. Okay, I'll talk about the last 4 in class. All right, they're a little more complicated, and I'll run out of time if I go to do those. All right, so a little tricky, I know, but if you need to review anything, go back. That's fine. All right, I will see you in class.